Hello students, welcome to the class of teacher Meenal Pereira on effects of electric current. Before we begin, I hope you all are taking proper care by staying at home. And of course, I am sure that just like me, you all are bored of sitting at home. But children, please stay and take care. You know children, nowadays, along with food, water and shelter, what is our basic necessity? Yes, it is electric current. So in this lesson, we will be studying about some of the effects of electric current. We will be studying energy transfer in electric circuit, heating effect of electric current, magnetic effect of electric current, electromagnetic induction and electric motor and generator. So, important lesson. Please pay attention. Let's begin. In these pictures, you can observe some effect of electric current. Let's study which are these effects. Okay, so what do we see is in the first picture, we see the electrical circuit or all the gadgets of electricity that we can see at home. In the second one, we can see a fan rotating, and in the third one, this is a structure of internal size or internal structure of a electric doorbell. So basically the above pictures shows the use and effect of electric current. The first picture shows the heating effect. The second picture shows the magnetic effect, and the third picture also shows the magnetic effect. Now let's study energy transfer in an electric circuit. Now children, last year about electric current we have studied some things in details. Okay, so in that we have studied about conductors, insulators, what are the good conductors, what are the good insulators. We have also studied about electric circuit, all the short form of it. Okay, so now we will begin with the main part of the lesson. Now in this derivation or in this part, we will be studying about energy transfer in an electric circuit. What is the material required is, we require connecting wires, we require electrical cell that is going to give the energy or potential difference. We need electrical resistance, which is denoted by letter R. This is to control the current. We need a voltmeter. This is to measure the potential difference in the circuit. We need an ammeter, which is denoted by A. This is used to measure the current. And then we need a plug key, which is important to start and stop the circuit or start and stop the current flowing in the circuit. Okay, now what's the procedure? We connect the circuit as shown in the diagram after taking the components with proper values, and we are going to measure the current I flowing through the circuit. Also, we will be measuring the potential difference, which is denoted by VAB. Now, why AB is because we are measuring it in these 2 points, point A starting from here and point B. Okay, so therefore the potential difference is taken between point A and B of the resistance. The potential A is at higher than the potential B, as the point A is connected to positive electrode of the cell. This is the point A which is connected to positive electrode of the cell, whereas point B is connected to the negative electrode of the cell. Then what is the outcome? If a charge Q flows from A to B, work VABQ has been done on charge Q. Okay, so charge which is denoted by Q that flows from A to B, then the work done that is denoted by sign W is represented as VABQ. What is the source of energy in the cell? Of course, we know that the cell gives this energy, or the electrode, what we call as electrical cell. This gives the energy. The cell gives this energy through the charge Q to the resistance where work VABQ is performed. If the charge Q flows from A to B in time t, that is the work is performed in time t, then during that time the energy VABQ is given to the resistor. So this resistor gets energy by the cell or by the current that is flowing through the circuit. Then what happens to this energy? This energy is received by the resistor and is converted into heat energy, and the temperature of the resistor is increased. Now very often we see children, when we use the electrical instrument, after some time the instruments become hot. So what is the reason is because of the heat energy that is produced. If in the circuit the resistor is replaced by a motor, in which form will the energy given by the cell get transferred into? So if it is motor, of course it will be transferred into mechanical energy. Now let's study a derivation. Now children, you can take a pencil in your hand and you can write the derivation in any book or rough book or in your science notebook along with me. Okay, so now let's study this. P, which is represented as electrical power, the formula of which is energy upon time required. Now energy is VABQ and time required is T. Now according to Ohm's law, which we have already studied last year, okay, so according to that what we can write is VABI, okay, because Q upon T is equal to I. Okay, now last year we have studied this formula, so this you have to remember. So I, current flowing through the circuit, is equal to charge upon time. So this Q upon T we are replacing by I. The source of energy the cell gives in time t, the energy P into T to the resistor. If I is the current flowing continuously through the circuit, the heat produced in the resistor in time t will be H heat is equal to P power multiplied by T, that is equal to VAB into I into T. Okay, so this VABI. Okay, so this P's value is this value, VAB into I and time T. Now according to Ohm's law, I is equal to V upon R. Okay, so now we will substitute this value of I into this equation. Okay, so then what we will get, H as it is equal to, instead of I, now what I am going to write, VAB into VAB upon R into T. Okay, so that is V multiplied by V is V square AB into T upon R. Okay, now again we know that V is equal to I into R. Okay, so H, again we will consider the equation with the this. So H is equal to I into R into T. Okay, so instead of this V, now what I am putting, I into R. Okay, so therefore I into R into R into T. Now one R here is in the denominator, so that one R gets cancelled. Okay, and therefore what we get is I square into R into T. Okay, so this is called as Joule's law of heating. Then going to the unit of electrical power. So P is equal to VAB into I, that is equal to volt into ampere. 1 volt is multiplied by 1 ampere is equal to 1 J joules into 1 C, that is coulomb. That is, these are the symbols or units. Then multiplied by 1 into C upon 1 into S, that is 1 joule second is equal to watt, or which is also denoted by a letter W. So the unit of electrical power is 1 watt. Okay, so this gives us the Joule's law as well as the unit of electric power. Now going to the heating effect of electric current. Here we can see a simple circuit. When a resistor is connected in an electric circuit, heat is produced in it due to the current. This is known as heating effect of current. Okay, so resistor is connected into the circuit, heat is produced, this is heating effect. Now let's see which equipments we are using or making the use of this heating effect of electric current. Equipment such as water boiler, electric cooker, electric bulb makes use of heating effect of electric current. Electrical conductors having high resistivity are used here. For example, a coil made up of an alloy nichrome. Nichrome means nickel and chromium. It is used in electric heater cooker as a resistor. So this is the coil of the cooker. Okay, so this is used as a resistor. It becomes hot and then we can cook food into it. While this is the coil of the normal heater. While a tungsten wire is used in an electric bulb. This is a structure how the electric bulb is going to look, and there we use a tungsten filament. Because of the current, this wire gets heated up to nearly 3400 degrees Celsius and emits light. Okay, so we are setting heating effect. So what is happening is, because of the resistance, heat, this tungsten wire is getting heated and the melting point of tungsten is very high. So therefore we are using this wire. Okay, so it becomes red hot but it doesn't melt away and we get proper light. So this is the reason why we are using tungsten filament in an electric bulb, because it is having a very high melting point. Then next we go to study the phenomena of short circuiting. Okay, so this kind of wires you must have seen at home. Okay, so several times we hear about building catching fire due to short circuiting. Sometimes if we switch on an electrical equipment in a house, the electrical fuse wire melts and the electrical supply shuts down. Let's see what is the reason behind it. Now you all know that we have three types of wire: earth, live and neutral. These are the old colors of the wire, green, red and black, and these are the new one. Now we all know that all these wires are insulated. Okay, inside we have a copper wire, outside we have a plastic cover. Now sometimes what happens, as you can see here, is sometimes due to certain things, maybe the coating of the neutral wire and the live wire goes. Then what happens? This neutral wire and the live wire comes in contact with each other, and that results into what is called as short circuiting, because two wires coming in close contact to each other. Okay, so if any inflammable material around that place is come, or if we have any inflammable material, it can catch fire. So therefore a fuse wire is used as a precautionary method. Okay, so previous standard we have learnt about the fuse wire. So as long as the high current flows in the circuit, the fuse wire melts and breaks the circuit, and this can be avoided. Okay, so fuse we can use, that will save our precious electrical instrument. Then going to the overloading. Now many times, especially in summer season, we use electrical power or so many electrical instruments like light, fan, air condition, fridge. So that uses too much of electricity. So what happens is, excessive current is drawn from the transformer supplying the electricity. And if the capacity of the transformer is insufficient, its fuse wire melts and the supply gets shut down. So such events occur due to overloading. Okay, so what happens due to overloading? As the name says, too much of load. Okay, so then the transformer gets shut down. Okay, and to avoid all the kind of different mishap, or to avoid the spoilage of our electrical instrument, these are the various types of fuse that we use nowadays. Okay, we also use the miniature circuit breakers or MCBs that are used at homes. Okay, so when suddenly the current increases or decreases, the switches opens and the current stops. So different types of MCBs are used, but for the entire house the fuse wire is used. These MCBs are mostly used for the entire building or entire big structure as such. Otherwise fuse wire is enough. Okay, so I hope it is clear to everyone. So we studied all these things. Thank you very much.